guys, welcome to Blessings YouTube tutorial. If you're new, you're welcome, and if you're old, you're super welcome. This video is concerned with paired t-test with a zero population mean. Alright, before we jump on today's topic in detail, please do well to subscribe to my channel, turn on the notification bell, hit the like button, and share this video. Thank you. Alright, let's take a look at the introduction here. Paired t-test, also known as dependent sample t-test or correlated pairs t-test, is used when one is interested in testing the difference between two variables for the same subject. When to choose a paired t-test. This test is chosen when you have two measurements on the same thing. For example, two tests on the same person before and after training. And the second example here, two blood pressure measurements on same person using different equipment. And lastly, determination of turbidity values from two stations of a river. And so we're going to take a look at the example we have on the board, and here we go. Question says, calculate a paired t-test of the following 10 pairs of samples gotten from two stations of a river for the determination of turbidity values in NTU. Test the hypothesis, which states that there is no significant difference between the turbidity values of the two stations at 0.05 probability level. This table shows the pair sample or data collected from two different stations of the river. The first station represented with S and the second station represented with Y, right? And so the first step in testing this hypothesis says subtract each Y value from each X value, right? So we're expected to subtract each of these values from these values. And of course, subtraction simply implies difference, right? We titled that D. So the first one says 12 minus 13. Of course, that gives us minus 1. Followed by 8 minus 12. Of course, that gives minus 4, right? And lastly, 10 minus 13, of course, that gives minus 3, right? And so step 2 says add all the values of D and determine its mean. So we're expected to add all these values together, right? Minus 1 plus 4 plus 1. And lastly, plus minus 3. And so the addition of those values, summation D, gives 10, right? And going forward, the question also said, and determine its mean. So we're expected to determine the mean of D. So we represent that with D bar. Of course, the mean will be 10 divided by the sample size. How many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So the mean will be 10 over 10, right? And of course, 10 over 10, 10 divided by 10, we have 1. So the mean of D is 1, right? Alright, this step says square D and add up all of the squared, right? So here we go. So we have D squared. So the first one will be minus 1 squared. Of course, that gives 1, right? Followed by minus 4 squared gives 16 here. Next, 1 squared gives 1, right? And lastly, minus 3 squared gives 9, right? And the instruction says add up all of the squared. So we're expected to add up these values, right? 1 plus 16 plus 1 plus 25. And lastly, plus 9. Summation D squared would be 116, right? Alright, step 4 says determine the degrees of freedom. Of course, we're talking about 10 pairs, right? So our DF, degree of freedom, would be n minus 1, which is 10 minus 1. And so our DF is 9, right? Next step says calculate the T statistics. And of course, the formula goes thus: mean D over square root of, right, summation d square, right, minus summation d all square, right, over n, right, and then all over n minus 1, right, times n, right. And so looking at our formula, we could see T equal mean D. That takes us back to mean D. Of course, the value is 1, right? And so we record that we have 1 over, right, root. So next we have summation D square. Of course, the value is 116 minus following the formula, and we have summation D all square. That takes us to our summation D, which gives us 10. So here we have 10 square, right? We have over n. Of course, our sample size is 10, right? We have over here, then n minus 1, that will be 10 minus 1, then times n. Of course, we have 10 here, right? And so going forward, we have our t equal 1 over root. Alright, we have 116 here minus, of course, 10 square means 10 times 10, which gives 100, right, over 10. So we have 10 here, right, over, and here we have 10 minus 1, that will be 9, right, and here we have times 10, right, 9 times 10, right, and move root. Here we have 116 minus, of course, we have 100 divided by 10, that gives 10 here, over 9 times 10 gives us 90, right, equal 1 over root. We have 116 minus 10, of course, that gives 106 divided by 90, right? And we'll go 1 over 106 divided by 90 gives 1.179, right, approximately. Root 1.17889 gives 1.0853, right? And so our t value is 1 divided by 1.0853 equal 0.9214. And so therefore, t calculated equal 0.9214, right? This step says, check for the critical value of t from t distribution table. And here we are looking at t at 0.05, right? Of course, we are looking at 2t here, degree of freedom 9 by our calculation, right? And here we go, t2 till 0.05, degree of freedom 9. So the value is 2.262, right? This step says, compare the calculated t and the critical t values. So we're expected to make comparison between these two, the calculated t being 0.9214 and the critical t, which is 2.262, right? It's obvious that calculated t is less than tabulated t or the critical t. So since calculated t is less than critical t, we accept null HO, right? And lastly, we are expected to draw a conclusion, right? And our conclusion would be based on the fact that we accepted null. So the conclusion would be there is no significant difference in the turbidity level of the two stations. And so we've been able to test this hypothesis that there is no significant difference in the turbidity of the two stations of this river, right? In our next video, we're going to illustrate how to determine paired t-test with a non-zero population mean. Thank you so much for watching this video. Please remember to subscribe to my channel, hit the notification bell, like this video, share, and leave a comment. Thank you. Bye.